All right, guys, let's go ahead and get started today. Make sure my audio is good. Yes, it is good. All right, so we're gonna do a quick 3-hour little cram session of Security Plus. Since I'm not in person, I won't have to take as long as breaks, so we'll probably just get through as much shit as I can right now, and we'll probably end at 12. I was thinking about it. Like, you guys need lunch. And then that'll just be it for the day and lunchtime. So let's go ahead and get started on these slides. So we're starting off on domain 3.1.1. Compare and contrast security implications of different architecture models. So there's going to be infrastructure concepts. And make sure in the chat it's only fat dubs, okay? No L's and no F's. All right, so the responsibility matrix, when we're talking cloud architecture. So this is going to be defining from the CSP's perspective, the cloud service provider's perspective, who is responsible for what in cloud computing. So we talked about this based off the service models, I think yesterday, where it really just depends what you're going to be responsible for. If you're deploying a VM in the cloud, you're still responsible for that operating system, patching that system, configuring IAM on that system. So that's something the customer would be responsible for. What the cloud service provider would be responsible for is maintaining the data center, the environmental controls, the power, providing console, internet access to the resources for the customer. So responsibility matrices, if you're using AWS, Azure, GCP, they're going to have their own that you have to adhere to if you're using those services. Hybrid considerations. So how do we do security in a hybrid environment where maybe we have on-prem architecture, then we also have some resources in the public cloud. So we're going to have to, so y'all can see it all. There you go. Get my face out of there. So this is going to be something you're going to have to consider in our modern day architectures. Now, when it comes to security, that could be as simple as enforcing what you have on-prem as well as you can in the cloud when it comes to maybe permissions, role-based access control, principle of least privilege. There's also solutions like secure web gateways, web application firewalls that you can deploy in the cloud. There's also something called a CASB, or CASB, which is a cloud access security broker that can help you take what you have on-prem as far as security policies and implement that in the cloud. You can also make that sort of like a man in the middle where users have to go through your CASB to get to their cloud resources in their enterprise. Third-party vendors. So managing risk when using external services. So this is just part of like really our supply chain, making sure we're vetting vendors properly and making sure we're doing our due diligence to understand what role we play in securing our architecture. What role does the vendor play? Going back to kind of that responsibility matrix, contracts come into this. Do we have an SLA? Do we expect some level of service from whatever provider we're paying? IAC. So how can we automate things in the cloud? Really automate things in our enterprise. There's a concept called infrastructure as code where we automate the provisioning, the management of our infrastructure. This infrastructure could be networks, virtual machines, load balancers, really any cloud resource. Maybe we don't have to go to the portal and manually click and create resources in the cloud. Maybe we use technologies like Terraform to do infrastructure as code. We make that part of a whole DevOps system. So infrastructure as code enables us to have consistent and repeatable environment setups. It kind of gets us to like a known good configuration that can be repeatable. Serverless architecture, or sometimes otherwise known as microservices. So this is serverless computing that allows us to run code, develop applications without having to do the back-end server management. So we call that microservices, functions as a service, platform as a service, but really the overall term we can use for that is called serverless architecture. Or maybe we're just utilizing databases like MongoDB or I can't remember the Azure service for it. That's going to kill me. But using databases in the cloud without actually managing the server or the underlying hardware. Okay, then microservices, small dependent services. This is the typical framework and architecture you're going to see now, especially on the web, having a bunch of microservices working together to run a web application or payload rather than our monolithic web architecture like I've described before. Network infrastructure. How can we properly protect network infrastructure? So we can have physical isolation or air-gapped systems. So physically separating networks to prevent unauthorized access, and then air gap is completely isolating a network from the internet and other networks. So this is like if you have an air gap network on ICS, industrial control systems. Those shouldn't have direct access to the internet. And if you have to troubleshoot, you have to go monitor, manage, whatever you have to do, you'll have to go into the actual area or into the actual systems to manage them. Logical segmentation and SDN. So some of the logical segmentation you guys may know that Security Plus tends to repeat itself because we kind of went over some of this already in Domain 2. But logical segmentation on the network could involve VLANs, doing layer 2, layer 3 segmentation, having ACLs to do segmentation. Then we have software-defined networking. Software-defined networking allows administrators to manage network services through abstraction of lower-level functionality. And what we mean by that is taking the control plane of all of our hardware, all of our fabric, centralizing that control plane, and then pushing policy, pushing profile and configuration to all of our hardware from a centralized device. That is software-defined networking. Okay, let's go ahead and do our quiz. I'm going to do the quiz with you guys. Let me bring it up. So we're on domain 3.1.1. Let's go ahead and take this domain quiz. Okay, question 1. Let me do this thing with y'all. Which of the following is a security implication unique to serverless architectures compared to traditional server-based architectures? So, security implication unique to serverless that doesn't happen or compared to traditional architectures. So, with serverless, a lot of that's on the cloud service provider. You're renting a service that you can then deploy your own custom code on. So you're going to have reduced visibility and control over the execution environment. You have lower costs, you don't do the server maintenance, and you have zero control over the underlying infrastructure. Question 2. What is a primary security concern when integrating third-party vendors in a hybrid architecture? So, there's a lot of things that could go wrong with this. So, when you integrate third-party vendors, doing the proper vetting is making sure that they're up to your standard of security, for one. But it also introduces just more complexity, so you could have some more tech debt, introducing another threat vector, so you have more exposure to vulnerabilities and risk. So we're going to go with C here. Increased operational costs. That's true too, though. If you think about it, if we're bringing in a third-party vendor, if it's a paid service, one, we're paying for that, so it's already an additional cost. But then we also may need to bring in experts or train our staff. So there's just going to be additional costs no matter what. But primary security concern, right? This is not a big security concern. That's more like an operational concern for our finance guys. Okay, question 3. Which of the following best describes the primary security benefit of using a well-defined architecture and infrastructure in an organization? The primary security benefit of using a well-defined architecture. Okay, let's look at our answers here. Enhanced scalability, reduced operational cost, improve security posture, increase operational flexibility. So we need to look at a security benefit. When I think well-defined architecture, that means someone came in, whoever it may be, an architect, an engineer, wrote white papers, use well-known frameworks, has good diagrams and good SOPs and a good content management base for everyone to look at. And then a well-oiled or a well-maintained infrastructure means that everything's up to date. So we're going to, with all of our paperwork done, all of our due diligence done, up-to-date hardware, we mean by patching, right? Doesn't mean the new hotness technology. Is we're going to have a better security posture because now quickly we can see probably a risk matrix, a risk register, see what systems we have and how they're configured, their IP addressing, ports and services. That's a well-documented architecture. So I'm going to go with C, an improved security posture. Okay, question 4. What is the primary security benefit of implementing software-defined networking in an organization's infrastructure? So we're not reducing the need for physical hardware. So SDN doesn't get rid of physical devices. It works with that underlying fabric of hardware to give you that single pane of glass and better control. So security benefit, it doesn't simplify. It actually kind of makes things a little bit more complicated for the networking team. It doesn't decrease overall network traffic. Your network traffic is going to stay the same. It doesn't optimize that. It could maybe on the WAN side choose different forms of transport to use that are optimized for your apps, but that doesn't decrease traffic. That's more of a quality of service thing. So we're going to go with enables dynamic programmable network configuration. And when we have that, kind of that consistency, it's easier for our security team to understand our network diagram and architecture. So I'm going to go with B. Okay, question 5. What is a security benefit of infrastructure as code? Again, it's not going to be A, but compliance. That's a good yes. We still need cloud service providers. The cloud service provider doesn't do anything for us, but provide the resources, right? How we configure it, they can give us a console, or we can use Terraform or like PowerShell for Azure, or even Ansible. It doesn't offer limited scalability for resources. It makes it easier to scale, makes things highly scalable. But really what infrastructure as code does is it makes consistency across your entire infrastructure. And we think of the way of compliance, we're in the finance industry. PCI just came out with a new requirement. We have to change something in our infrastructure based on a PCI compliance change. Well, if infrastructure as code, instead of us doing this individually on every single piece of device, hardware, resource in the cloud, we can send a single script to update all of our appliances and resources. So automated compliance. Okay, last question. In a cloud computing environment, which of the following best describes a shared responsibility model? It's going to be C. There's no negotiation. No one is solely responsible for anything. It's a matrix. There's different responsibilities based on the resource you're using in the cloud. All right, let's go. 100%. Okay, let's take a 5-minute break, guys. I just want to drink some water real quick. Let's come back at 9:50, and we'll continue. All right, let's go ahead and continue. So now we're going to go over part 2 of domain 3.1. Let's present this bad boy. Okay, domain 3.1.2, compare and contrast security implications of different architecture models. All right, let's go ahead and continue. Infrastructure concepts part 2. I keep getting this feedback. Hold on. Mute. Okay. All right, we're good now. Okay, so on-premise architecture. So on-premise is any infrastructure and applications hosted within an organization's physical securities. This is your local data center. There's a comms closet. This is what enterprises were made of, just on-prem infrastructure that we had full control over. And we call this capital expense compared to operational expense in the cloud. Well, obviously with this, there is no responsibility matrix. You are responsible for it. So whether you're the IT team, the SOC, network team, DevOps team, on-prem infrastructure, you're going to be responsible for. So it is potentially more secure since you have more control. So you may feel more comfortable with all that control to properly secure it. But now you have to worry about physical security, environmental hazards, and actual power to the data center. Where compare that to the cloud, you don't have to worry about any of that. Then obviously cloud-based services are from a third party with a shared responsibility. So here's the top 10, but really the big 3 is what you want to look at. You're looking at jobs in IT where not directly working for these cloud providers. Let's say you're going to work for an organization and you're going to be their cloud administrator. You're looking at AWS, Azure, and Google Cloud as the top 3. Okay, centralized versus decentralized systems. So centralized systems are where decision-making and processing are done by one central unit. You see this a lot with authentication. So centralized identification or authentication, where you have an identity provider like Google that's providing all the authentication. And then we have decentralized systems. This would be a good example of blockchain or distributed computing. This is where decision-making and processing are spread across multiple units. Virtualization. So virtualization is when we take a single piece of hardware, a bare metal server, and we put a hypervisor on top of that. And then that hypervisor is going to control the physical resources and allocation to individual virtual machines, individual operating systems, individual computers. So we have 2 types of virtualization. We have type 1 and type 2. With type 1 having a bare metal server with just a hypervisor engine installed on it, then that hypervisor engine is going to manage, deploy, and monitor our VMs. Then we have type 2 virtualization, which you may be used to. That's on your computer. That's where you have your your infrastructure, your computer. You have your host-based operating system, and then you install a hypervisor application. Then that application allows you to deploy virtual machines. Containerization. So containerization is when we have a shared kernel and a container engine on top of the operating system to deploy lightweight, what's called container images, so that we can deploy multiple different apps at scale. So these are lightweight, they're more resource efficient, and if we want to have an application, we don't need an entire operating system behind it. We can put it in a container image that has all the dependencies. So notice the big difference here. With containerization, we just have our operating system and container engine, and then that container engine's running all these different applications in these individual containers. Whereas with virtualization, you have a whole guest OS that you have to manage per app. So you have a single operating system per app. So that's kind of inefficient. With this, we can utilize the entire infrastructure for all these different lightweight containers that are hosting our applications. Okay, IoT. So IoT stands for Internet of Things. This is the interconnection of uniquely identifiable embedded computing devices. Long definition to just describe your smart TV, your smart thermometer, or AC, your smart washer. As far as security goes, IoT devices are inherently insecure because when manufacturers make these, they're not going for cybersecurity. The intention is that it goes in your house and it's not going on an enterprise-grade network that leaves you open for exploitation because you're introducing something to your attack surface like an IoT device that has default credentials, no encryption. If you end up having to put an IoT device in your enterprise, make sure you segment it as best you can. The default VLAN that we use for IoT devices is usually 107 because it looks like IoT, like the number 107. But anyways, move on. Just make sure you segment it. Other network architecture we're going to talk about is OT environments. OT, operational technology environments. This is like our manufacturing plants, our factories. And there's specific terms that we're going to describe the infrastructure of these factories and this OT. So it's going to be ICS and SCADA. So ICS stands for Industrial Control Systems, and SCADA stands for Supervisory Control and Data Acquisition Systems. These are both used to control industrial processes. This is just manufacturing, okay? Often, you have a lot of legacy equipment in here. Because if you think about it, if I'm building a dam, I've never built one, but I just imagine myself, I'm a dam builder, right? I'm building a factory that's supposed to pump out products for my organization. I'm going to build it to last. I want to build it so that I can get maximum efficiency and profitability out of that factory 24/7 without having downtime for updates and upgrades and all this craziness. So a lot of times you run into devices, OT, technology that keeps running for a long time but has really outdated security, and the companies are unwilling to update it because they're like, hey, it works. Figure out another way to protect my system without bringing it offline. So you have what ends up happening, a lot of compensating controls in our OT environments. RTOS, real-time operating systems. These are real-time application processes that process data as it comes in. So like if you purpose-built a Raspberry Pi to have a specific function, that would be a real-time operating system. Embedded systems. These are just computer systems with a dedicated function. They're not going to be like our desktop operating system that hosts a bunch of different apps and a bunch of different functionalities. And embedded systems often going to be purpose-built as well. It's going to be a computer system with a dedicated function within a larger mechanical or electrical system. Okay, another concept we're going to talk about. High availability. So high availability. These are systems designed to remain operational for a very high percentage of time. Kind of a good definition, way to describe it. But this involves a lot of administration, a lot of engineering involvement. In the cloud, we can have a high availability system by placing resources in different regions. So if one region comes down, the other region can take over. In our data centers, we have things called hot, warm, and cold sites that provide us high availability. At just a lower level, let's say we have routers in a first hop redundancy protocol. That provides us high availability, where we have two routers acting as a single gateway, and if one fails, the other one can take over. We also have hot standby deployments of things like our wireless LAN controllers or our call management system. So that's for our collaboration in our wireless networks. Okay, let's go ahead and do our quiz. So we're on domain 3.1.2. Come to my lessons here. 3.1.2. Let's take this quiz. Okay, question 1. Let me just fix some things on my other monitor. Question 1. In the context of containerization, which of the following is a key security benefit? So we're looking at A and C here. So containers require less frequent updates than virtual machines. That is inherently, that's inherently true. That containers do require less frequent updates because a container is not a whole operating system that we have to maintain, right? So that's true. C, containers enhance portability and reduce the attack surface. That's also true because a container is lightweight. It just has exactly what it needs to operate that application. So less of an attack surface, right? Less of a threat vector, unlike a Windows server, which could have a bunch of ports and services open that are unneeded for what you're using it for an actual application. So I'm going to go with C here. So the explanation. Awesome. Question 2. Which of the following is a primary security concern for on-premise architecture? So on-premise architecture, that is when we have full control, right? We have to worry about everything from power, HVAC, environmental, physical security. So what's a primary security concern? Limited physical access control. It's not going to be dependency. It's not going to be high scalability and flexibility. That would be more of the cloud, the high availability and scalability. So I'm looking at either A or D. Limited physical access control. Because primary security concern, yes, we have full control over hardware and data. But that's not our primary security concern. Because what this is trying to do is kind of get you to compare why when we have this versus the cloud, now what do we have to worry about? We have to worry about the actual physical access control. So I'm going to go with A. If you chose D there, I don't think that's a bad answer. But I think more accurately, we're looking at A here. All right, question 3. Which of the following is a common security challenge in both IoT and ICS/SCADA systems? So high computational power, that's not going to be it. Frequent firmware updates. That's not a security challenge. We want to make sure that isn't happening because remember, in cybersecurity, it's not just our job to secure at all costs. There's a profitable business that we have to enable. So that's not what we're worried about. Standardized and open protocols. That's not true either. A lot of times in ICS or OT environments, you won't even have Ethernet. You'll have things like Modbus, different controls. We're going to go with C here. Longevity and legacy systems. That's really it because these things last so long that they become legacy and then we're dealing with a lot of compensating controls. So I'm going to go with C. Oh, in the chat, Stephanie. No, segmentation is putting it in a different VLAN, giving it a different subnet. Changing a password is just hardening it. There's a lot of different things you'd have to do for IoT devices to make them more secure. Okay, question 4. What is a primary security concern in a virtualized environment? So I'm looking at A or B here off RIP. When it comes to a virtualized environment, because we are dealing with hypervisors, that's what accomplishes the virtualization. Our hypervisors controlling the physical resource allocation to our virtual machines. Physical hardware maintenance, obviously that's involved, because if we're virtualizing a server, we still have that physical server. But I think more accurately, we're worried about hypervisor vulnerabilities. Things that could also happen in the VMs, like VM escape, sandbox escape, things like that. And if someone gets access to our hypervisor, then we're really screwed. I've even seen in certain environments, I've read on forums too, of organizations exposing the hypervisor IP address to the internet. Because it's like whatever VMs are in their ESXi server, their hypervisor, it's for the internal and external internet access. But the actual hypervisor itself will get an IP, and you don't want to expose that. Because if someone gets access or exploits a hypervisor, you're screwed. Your entire virtualized environment is done for. Question 5. Why is high availability a critical requirement in systems using RTOS? So real-time operating systems, those are usually purpose-built and they're processing data at speed. You see this in manufacturing. You see this just in even I have Unify, Air Fiber. There's going to be a real-time operating system in that antenna, right? So they're mission critical. They're mission critical applications. So we want that redundancy. So I'm going to go with C here. All right, last question. Let's try to get that 100. So question 6. Compared to centralized architectures, decentralized architectures are primarily characterized by... So decentralized is when we have a distributed computing system that has all the nodes agreeing on whether something is authenticated or is correct. Kind of like how blockchain works, but that is a decentralized system. So the centralized system, let's just look at a centralized system in terms of authentication. How do we authenticate to our third-party apps? Well, we use a big identity provider, something like Google. So you can sign into our Trepa Tech Academy, this website I'm on right here, using your Google sign-in. Well, we're a third-party app in the perspective of Google. So Google's that centralized identity provider. So you're relying on one entity to authenticate you. Now, with decentralized architectures, that's not how it works. Everybody would be their own identity provider, and everyone would be agreeing on an identity or authentication. So I'm going to go here with C, enhanced fault tolerance and resilience. All right, awesome. Let's take a 10-minute break, guys. My voice is suffering right now. Let's come back at 10:15. Okay, let's continue. So now we're going to go over considerations, finishing up domain 3.1. So resilience of a system. So how resilient is it? So this is the ability of a system or network to withstand and recover quickly from difficulties or challenges. So this involves us planning for failures, doing regular testing exercises as well, and also having dynamic adaptation. Also considering like your geographical region too. Like, let's say you put a data center in California right now, in an area that's known for wildfires, you'd probably be fucked, right? So that's also something when it comes to resilience is if you're setting up, deploying backups, put them in a different geographic region. Like if you put a data center in the middle of a hurricane region, Tampa, Florida, you can expect at least once a year shit's going to be fucked up. Okay, cost. This is a financial consideration of implementing something. So do we have capital or operational expense, and does that fit into the company's budget? Responsiveness. So this is the ability of a system to respond and adapt quickly to changes. So this is like how your scalability is. If you have a peak hour all of a sudden, can your systems respond accordingly without intervention? If it requires intervention, do we have the proper monitoring systems to alert somebody to quickly scale up or elastically scale? And with that comes scalability. Can it even? Do we have systems that can scale? Or if you need to, are you pretty much screwed and you have to go buy a new server from a vendor? Or are we in a cloud scenario where it is allowing for scalability? So can we actually even handle increased loads? Easy deployment. So do you need easy deployment? Is it easy to spin up and deploy new systems? Or are we going to have to integrate it into a whole patching system? When it comes to making code changes, do we have good CI/CD pipelines created to integrate our code easily and quickly? Wonder if that's just Starlink. I wanted to get a Starlink Mini. That shit would have been sick. But anyways, let's move on. Something else we have to consider is the risk. So what's our risk appetite in an organization? Now, we have a more fine-tuned PowerPoint going over the different types of risk in an organization, but risk transference, this is the practice of you having like a mid-level risk appetite. And what we mean by that is you may not want to invest in upgrading systems as an organization, but you don't want to just be like hands up, oh, that sucks, we got data breached, our data got breached. So you may do something like risk transference, which is usually buying cybersecurity insurance. Definitely know this term. Risk transference is transferring the risk to another party, typically through like cybersecurity insurance. Easy recovery. If we do get breached, if we are exploited, we have to isolate, we have to quarantine, we have to do our backups. What's our easy recovery? Do we have well-known good baselines? Do we have I just talked about it with you guys yesterday, but a point, like good snapshots for our VMs, or a good restore point for like our individual systems. Patch availability. Are we integrating a good patch system? Are the vendors supplying us with patches? And do we know when our end of life, end of cycle is? Are we doing regular updates? You have to have something in place for patches and for updates. For as long as we have technology, there will always be updates. On the flip side, maybe you don't want to be too patch heavy. And what we mean by that is, if a new patch comes out, you don't just automatically deploy it, because that may bring something down, and then we can't make money as a business, and then that's your job. Inability to patch. So if this is true, we have a legacy system, we don't just give up. Now we have to start doing some mitigation planning, some risk management, we have to start implementing compensating controls, putting that legacy device into an isolated VLAN, setting up the correct firewall rules, things like that. Other considerations, power and compute requirements. So we have to consider what kind of power we need. Do we have redundant power? And do we have enough compute resources? When we say compute resources, that could be for the users. So like we see here, do we want thin clients for the users? Do we want desktops, laptops? Do we need a CPU or GPU heavy server, depending on the applications we may be managing and deploying in our enterprise. So those are some considerations we may have as well. All right, let's go ahead and do that quiz. Let me zoom out here real quick. Oops. We're on domain 3.1.3. Let's go do our quiz. Okay, question 1. What is a significant security concern when there is an inability to patch a system component? Yeah, it's just the system's vulnerable. If you can't patch the system, if they have a known CVE, it's going to be exploited eventually. If we do nothing, right? Or at least it can be. Question 2. What does risk transference typically involve in the context of security architecture? It's transferring. It's not shifting responsibility of risk management. Risk management is always going to be on the organization itself. You decide your risk management, right? But what does it do for you? It transfers the cost in case you get breached. So we're going to go B. Transferring the financial cost of a risk to another entity, such as through insurance. Question 3. What is the primary security implication of scalability in an architecture model? So what is the primary security implication of scalability? So I didn't really touch on this in the slides. Let's go over it. Scalability, it does affect security in a way that, let's say we don't have an already hardened VM that we can scale out. What I mean by that is sometimes you'll have like a base image in the cloud. I'm thinking in the cloud perspective. And you may scale that out, but then there may be some automation you have to do after the fact of and putting that in the right firewall. There's just certain scenarios where when you scale out, it quickly scales, and you may miss some of the hardening you did from that base image, because some things don't always come with that clone image. And so it may introduce more of an attack surface or more vulnerabilities. So I'm going to go with C here. Scalability can introduce new vulnerabilities, especially when scaling out. Question 4. What is the primary goal of building resilience into a security architecture? I'm going to, off rip, probably go with D. Because remember, resilience can it recover? Do we have redundancy? What's our primary goal is that, again, what our primary goal should always be, and that is making sure the business stays profitable. Enabling the business to run. Enabling the business to have maximum efficiency for the people that make the business profitable and give us a living. So we're going to go with D, to enable the system to withstand and recover from disruptions. You know, I wonder if I can do a poll in here. I know I see my favorite creators do it, but fuck it. We don't need to do all that. Okay. Which of the following best represents a common challenge when balancing cost and security in an architectural model? Okay, let's see. Best represents a common challenge when balancing cost and security. I mean, yeah, this is actually just kind of an easy question. A little long, but when you read it, it's the same challenge in every business. The cost and complexity. And with complexity comes cost, because the more complex a system gets, the more training for your employees, the more time the employee has to work on that system or architecture. Maybe you have to hire outside. So it's going to be, if you increase the cybersecurity, there's always going to be a cost-benefit analysis that has to be done. Does this make the system less usable? Does it make it less available, right? Okay, last question. Which of the following best describes the concept of availability in the context of security architecture? I harp on this a lot, actually, to making sure your systems are highly available. Because I just hate when you get engineers that are just implementing technologies to implement them, and then it's like dude, we didn't need this. Like, we were working just fine, and now we got to learn a whole new system that may not even increase our efficiency. But anyways, sorry, a little personal anecdote. As you may see, the system's ability to be accessed and used as intended by authorized users. Let's go, 100%. Okay, let's move on now. Let's go into domain 3.2. Okay, so domain 3.2.1, given a scenario, apply security principles to secure enterprise infrastructure, and we're going to go over infrastructure considerations. Here's our objectives. So infrastructure considerations, just different ways we're going to plan our infrastructure. And then in this domain, we're also going to go over the different network appliances we have to be aware of. Okay, infrastructure considerations. So infrastructure considerations involve the strategic planning and setup of an organization's network architecture to ensure robust security and efficiency. So when we talk about enterprise-wide, there's so many considerations. There's a lot of things we have to consider, right? It's the name of the PowerPoint. But it's Wi-Fi. It's placement of our wall jacks. It's placements of our IDF and MDFs. That's where like our comms closets are and our patch panels. It's the placement of physical location of things. Are we close to the ISP when we build our comms closet with our core router? And then beyond that, as from the cybersecurity professional, is okay, is everything redundant? Is it resilient? Are we having systems and SOPs in place so when I build out one office and I build out another one because we're expanding as a business, is it going to be the same? Are we doing a multi-vendor environment? What vendors are we going with? Do we have good relationships with the local ISPs? Are they giving us good internet connections? Are we building it in a way where we're at 60% capacity and can scale up to what we believe would be 100? And what we mean by that is we always want to give ourselves about 40 to 50% of breathing room as far as uplift and scaling goes. Okay, so let's get into it. Device placement. Device placement is strategically positioning network devices to optimize security, performance, and reliability of the network infrastructure. Commonly, we see this in Wi-Fi, where we have to do a lot of Wi-Fi analysis, do our scans to see where we can place access points, their range, what kind of antennas, and if we have any dead zones. Security zones. So physically, in the human realm, are we going to have zones of interest that we don't want people coming into? Meaning that you need explicit or mandatory access, explicit permission or mandatory access to get into this area. What kind of controls do we have there? Is it man traps? Is it roaming guards? Is it just biometric readers? But then people can tailgate that. So do we need controlled access points? Attack surface. Have we identified our attack surface and at least written down what we need to protect? In security, we always want to have a good defense in depth countermeasures and planning to protect our enterprise. And before we can even decide to protect our enterprise, we can't just start doing network scans like, oh yeah, close that port here. We should probably take a holistic view and look at our entire attack surface and say, okay, here's A through Z in backwards plan how we're going to reduce that attack surface, reduce threats, and actively search for any vulnerabilities or where we could be vulnerable. Connectivity. Do we have the optimal connection based on our location? This deals with ISP. This deals with cloud service provider. This deals with, are we using VPNs? Do we have SD-WAN? Do we need a backup broadband connection? Do we need a dedicated MPLS circuit? So we want to make sure our connections are stable while also providing the most bandwidth and providing redundancy. And that's either external to the WAN, but it's also internal on our campus networks. Are we making sure there's no switching loops? Are we making sure that our campus networks are designed in a way that's efficient for our users to access the local resources as well as access cloud-based or internet-based resources? Failure modes. So in case of failure, how do we build our infrastructure? So we have fail open. And a fail open scenario refers to security system defaulting to allowing access or continuing operations when it fails or malfunctions. Fail close. In a fail close scenario, the security system shuts down the operation or access it controls in case of failure or malfunction. Device attributes. So device attributes are inherent properties or characteristics of a device that defines its role, capability, and behavior within the network. We can use these attributes to go a step further than just role-based access control and start implementing something called attribute-based access control, using certain attributes to define roles and permissions. Active versus passive. This refers to whether security systems actively intervene in network traffic, active, kind of like almost an IPS system, or just monitor and report and alert, which would be a passive system. Inline versus tap/monitor. So when you're doing an inline device, that's directly in line of that data flow, and it's going to influence that network traffic, whether that be to block or modify. A monitor device, that could technically also be in the direct path. Typically, it's maybe going to be outside the direct path of a data flow from like user to web server, but that's just going to observe and record network traffic without altering it. All right, let's do our quiz. So this is domain 3.2.1. Come here to lessons, domain 3.2.1. Scroll down and let's take our quiz. Question 1. Which of the following actions is most effective in reducing the attack surface of a system? So the attack surface, that's anything that could be vulnerable in the system. We're going to go with C. Disabling unnecessary services and ports. Question 2. In a network security setup, which type of device would directly intervene and possibly alter network traffic based on predefined security policies? It's going to be an active device. All the rest of these, remember, they just report. They don't influence the network. They don't intervene. They don't stop potential data exfiltration. They don't look at anomalies in the baseline behavior and stop the traffic. An active device will intervene. An active device will intervene in that traffic. Question 3. In a high security environment where data protection is prioritized over maintaining continuous operations, which failure mode is preferred? So data protection is prioritized, meaning that if we think there's been some sort of breach, there's a risk, there's a vulnerability that may be exploited, we care more about protecting the data than continuing operations. So we have two options here, fail open or fail closed. And if we're prioritizing data protection, that's going to be fail closed, where we cut off the traffic. Question 4. Which type of security device placement is characterized by observing and recording network traffic without altering it, thus providing insights without impacting traffic flow? Device placement. So you're probably looking at this and say B and D, right? So a passive device describes a device that says, hey, you're not going to do anything. You're just going to record. But we're talking the actual device. Like, how do we describe the actual placement of a device like that? That's going to be a tap or monitor. So yes, B. Good job, Charlie. Question 5. Which of the following best describes the primary purpose of implementing security zones within a network infrastructure? Security zones, I mean, it's just a segment, right? That's going to be the segment. And when we segment, we have better granular control over that type of traffic that we're segmenting. So let's take a look at these answers. To centralize, hell no. To segregate the network, yeah. To monitor and filter out, not necessarily. It's not to filter. To increase the network's bandwidth and performance, no. That can be a byproduct sometimes. But the primary purpose is going to be B. To segregate the network into areas with distinct security policies and controls. All right, another 100%. What time is it? 10:36? Okay, I'm going to give my voice a little break. Let's come back and Okay, 10 minutes. Yeah, we'll come back in 10 minutes. Let's come back at 10:45 and we'll continue. Alright guys, let's go ahead and get started. So now we're going to go over domain 3.2.2, different network appliances. So let's jump right into it. This is going to be all the different network, pretty much the hardware, the architecture, appliances you will see on the network. Okay, so a jump server. A jump server acts as a secure and controlled entry point into a network segment or environment from a different network, especially for administrative tasks. What we're talking about here is just pretty much almost like a man-in-the-middle server that allows you to not get direct access to like the data center or your ICS controls. If you want to remotely manage it, you got to go to the jump box first, and then sourced from the jump box or from the jump box, then you can get into your different environments. Very, very common in big enterprises that will have those different kind of IT or OT environments. Okay, proxy server. So a proxy server acts as an intermediary between end users and the internet, providing security, administrative control, and caching services. So we have two major types. We have a forward proxy and a reverse proxy. As you can see here, the forward proxy is users connect to that proxy in their environment, and then that proxy sends their traffic to the web servers. Where the reverse proxy is that the users believe they're connecting directly to the web servers, but they hit a proxy first, and that server will actually run that connection. So besides just being like that kind of man-in-the-middle protection, it can also do a little bit more. They can do content filtering. It can cache certain things to make your web traffic a little bit more seamless. You're not loading so much during every session. It also can mask the IP addresses for the web server. IPS and IDS, we've kind of talked about this a lot. Like I said, Security Plus sometimes likes to repeat itself. IPS intrusion prevention systems can be inline on the network or on the host. They prevent things. They'll actually stop traffic. The IDS just does alerting. And again, an IDS system can be on the network or the host as well. A load balancer. A load balancer is going to be able to efficiently distribute incoming network traffic across multiple servers, and is sometimes needed with high throughput links or just high utilization servers. All right, sensors, typically in OT environments, but in a network, sensors are deployed to detect and respond to changes or events, providing data for monitoring and security purposes. They can also do data collection as well and then send that data to a centralized server, maybe like a SIEM or SIEM system. Port security. I talked about this with network access control earlier in the week as well. This is a layer 2 traffic control function that allows you to control how many MAC addresses can be learned on an individual port, so you are not exposing yourself to things like frame flooding attacks on your switch. 802.1x. This is also part of network access control. This is a network protocol that provides an authentication mechanism for devices wishing to attach to a LAN or a wireless LAN, trying to get access to your network. So this does port-based network access control. It's different than port security. That's just limiting MAC addresses. This is actually going to authenticate your device. It's going to authenticate your device and authenticate your user and say, okay, yes, we're going to grant you access now. Not based off a MAC address, but based off actual device attributes. EAP, Extensible Authentication Protocol. So EAP is a framework that supports multiple authentication methods for securing network access and communications. It has flexibility. So there's a bunch of different EAP protocols out there that you can implement. This image down here is an example of EAP TLS that uses the transport layer security, that Cipher suite, to help with the protection and authentication protocols of a wireless network. All right, then firewalls. We have different types of firewalls. We have firewalls that filter based off layer 3 and 4 information that will be stateful or stateless. Then we have deep packet inspection firewalls or next generation firewalls that can actually look into your data payload and filter based off your content or maybe your URL. Web application firewalls. This is a dedicated appliance that just monitors HTTP traffic. So this is going to help us protect against those injection attacks. Any kind of attack or threat that comes via the hypertext transfer protocol. And then UTM. This is an all-in-one appliance that can do everything we just talked about, all wrapped up into a single device. You're not going to really go out and be like, I want to buy UTM. What will happen is you may buy a router or a firewall or some sort of piece of hardware, and then that vendor that makes it says, hey, you may be buying this router to do its base function, its primary function, which is route traffic to and from your network. But we also have these security features in it. And with those security features enabled and you using them, then all of a sudden that becomes a UTM, a Unified Threat Management device. Okay, layer 4 and 7. So when we are monitoring, filtering traffic, commonly we can monitor via layer 4. That's where we check the ports, the protocols, and filter based off that. Or we can do it based off the application, where we say, hey, let's actually focus on the payload, what's actually in this hypertext transfer request, and we'll filter based off that. Okay, I'm not going to do the quizzes anymore, guys. I'm just going to give you guys about 2 minutes to finish them, and then we'll move on. Okay, let's continue. Now we're going over domain 3.2.3. I don't want this view. Let's present full screen. This is going to be going over secure communication and selection of effective controls. Okay, so VPN, so a virtual private network. So a VPN establishes a protected network connection when using public networks. It encrypts internet traffic and disguises online identity, enhancing data security and privacy. So VPNs also provide encryption. Now, different VPN types will have different encryption, but it establishes a secure tunnel for data transmission, safeguarding the data payload. It also provides remote access. That was kind of the original why VPNs were created in the first place, was to give spoke sites direct access to like the HQ site. And now remote workers, they use VPNs to access the enterprise. And yes, a byproduct of that is encryption, but the original point was to get you access back to the enterprise when you're not on that intranet. Okay, remote access. So remote access allows users to connect to a network from a distant location. enabling them to access resources as if they were directly connected to the network's main infrastructure. So this provides flexibility. So this enables employees to work from any location, increasing productivity and efficiency. Security risk. This exposes networks to potential vulnerabilities, hence requires robust security measures like VPNs. Tunneling. So tunneling is what makes VPNs possible, hiding that layer 3 header, or putting a new layer 3 header, encapsulating it. So tunneling encapsulates a network protocol within packets carried by a second network, enabling the secure passage of data across an intermediary network. Pretty much put a new IP header on it, send it throughout the internet until it reaches its destination. TLS, transport layer security. So TLS is what enables our HTTPS connections, HTTP secure connections. So TLS is a widely adopted security protocol designed to facilitate privacy and data security for communications over the internet. TLS has cipher suites, which are enabled by the public key infrastructure, so that our client to web server architecture across the whole internet is secured from end to end. IPsec. This is another suite of protocols that is going to secure internet traffic. So IPsec will be very similar to TLS, but this is typically done on site-to-site connections, meaning we build IPsec tunnels from firewall to firewall, firewall to router, VPN concentrator to VPN concentrator. And this is going to be a suite of protocols that provides us authentication, encryption, and non-repudiation. SD-WAN. So SD-WAN is a virtual WAN architecture that allows enterprises to leverage any combination of transport services to securely connect users to applications. So SD-WAN enables that centralized control and single pane of glass for our multiple forms of transport from all of our offices. So if you have an office with a dedicated MPLS circuit, a couple broadband connections, 5G and Starlink, if we deploy an SD-WAN appliance at that WAN side, we can control that between all of our branch offices and start prioritizing traffic through those multiple forms of transport. And it also gives us that cost effectiveness and the centralized management for it. SASE, or Secure Access Service Edge. That's going to combine SD-WAN with a lot of security functionalities. So SASE converges network security functions with WAN capabilities to support dynamic secure access needs of the organization. So SASE is very common now. It also is going to give us that single pane of glass, not only for SD-WAN, but also for security functions like Secure Web Gateway and Cloud Access Security Brokers, which are functions or technologies or applications that are going to secure our cloud-based resources. It lets us have firewalls as a service, or really network functions as a service. So we get that filtering into our cloud, into our enterprise from our SASE appliance instead of having that dedicated hardware appliance. And it's also going to help us have zero trust network access. So it's going to be part of our zero trust network architecture or infrastructure. So selection of effective controls. So when should we use any of these controls? It obviously all depends on your environment, what's the most cost effective, and if you need to. If SASE is needed to help you get in compliance with the industry you're in, and there's a cost of benefit analysis done, and it'll overall have improvement for your IT organization or your organization period, then maybe you choose that control. If it's not needed, then maybe we don't need it. Okay, let's do our quiz. So you guys are going to do quiz domain 3.2.3. Put another little 2-minute timer on there. Okay, now let's move on to domain 3.3. We're going to be going over compare and contrast concepts and strategies to protect data. So now we're going to go over the different data types and different data classifications. Classifying our data and kind of putting it into a type of data is going to help us with our data loss prevention. So before we know what we have to protect from being exfiltrated, we have to classify it, right? And then that classification will be used in our data loss prevention systems to say, hey, this is confidential. It's a confidential tag. So we got to make sure it's not being exfiltrated to an unknown destination IP. But then also helps us in training our employees. So data types. Regulated. So data bound by a legal or regulatory requirements needs stringent protection measures to avoid non-compliance. And what I mean by that is if we're in the industry that has a regulation we have to adhere to, then our data is regulated and it has to be in compliance with whatever industry we're in. This could also be geographical. We could have to worry about data sovereignty laws, like customer information in the EU. They're under the GDPR. That's the General Data Protection Rights that EU customers, anyone living in the EU is protected by. And if we're doing business in the EU, we have to follow the GDPR. Trade secrets. So if our data has a trade secret on it, we're also going to have to protect that. We have to have NDAs built for that. Physical security measures and security measures that help us protect our sensitive information like trade secrets. IP, intellectual property. So this is anything that is invented that could be potentially be copyrighted. So protect against IP, it's going to be the same thing. We're going to have NDAs, AUPs, acceptable use policies created, things like that. Legal information. So this is information related to legal proceedings or contracts that is highly sensitive and requires a lot of confidentiality. So imagine you're doing IT work for the court systems, for your local government. There's probably going to be more stringent permission-based controls, or it's going to be very important in that type of environment versus maybe like someone doing marketing where they're sending user information to everybody. And storage especially. How do we store legal information? What's our destruction timeline like? Do we keep legal information for 25 years and then how do we properly destroy it? If we do get breached, do we have the right plan in place to talk to the public about that data breach? Financial information. So obviously financial information is going to be, again, very stringent based off the finance industry's regulations. PCI obviously is the first thing that comes to mind. Human and non-human readable. So there's going to be data in formats directly understandable by humans, so text and images, or non-human readable information, machine code or encryption. So two different data types there. We don't really deep dive into that. So now let's go over the different ways we can classify it. So in the government, we have our classifications that are pretty easy to understand. It's going to be unclass, confidential, secret, and top secret. That's probably easy for us to understand. But in the private sector, we don't have to label things like that because we don't have different enclave networks like that. So how can we classify our data? Well, this is how CompTIA describes it. So sensitive information. This is data whose unauthorized disclosure, alteration, or destruction could cause significant harm is classified as sensitive. Confidential. This is data that requires restriction of access to prevent unauthorized disclosure is classified as confidential. Public. This is data that can be disclosed without harm or loss is classified as public. So in a private sector, this is going to be anything on your like front end website, right? That's public information, things you want the public to know about. Restricted. So just another way we can classify things. So this is data with very high sensitivity, often subjected to legal or regulatory restrictions, is classified as restricted. So access to restricted data is extremely limited, often only on a need-to-know basis. So back to that need-to-know basis, remember that's mandatory access control. Then we have private. Now you guys may be wondering like, damn, this kind of all just seems the same, and yeah, like restricted, confidential, sensitive, private. What's the difference? It really just comes down to how you want to interpret the definitions. We're going to pass the Security Plus exam, so we're going based off CompTIA. These are definitions pulled from like the CompTIA official reading. But in your private sector organization, let's say you get a federal grant to do some research and development, and that's potentially you're inventing or creating something in that organization that could be copyrighted. It doesn't matter if you label it sensitive, confidential, restricted. You just need to label it in a way that says, hey, if you want access to the data, you got to go through these formalities. You got to go through these permissions, need to know access, sign an NDA, sign an AUP, sign these things. And we're deciding as a C-suite, as an organization, we're going to make this R&D, research and development data sensitive or confidential or restricted, right? So, but private, this is personal. This is typically personal data. This will be like PII or PHI, and that's classified as private information. And then critical. So this is data essential for the operation of an organization is classified as critical. So critical data requires the highest level of protection with robust redundancy and disaster recovery plans. So again, that's up to you to decide. Here we have like just a Google image doc with the top secret label on it. But I mean, in this private sector, you may not have that, right? If it's critical, that pretty much means like, hey, this data, maybe we need it to be profitable. So we're going to consider this critical data. And that's going to change how we treat that data, how we protect it from the cybersecurity perspective. Okay, let's go ahead and do this quiz. And then we're going to take probably our last break. We'll take a 15-minute break. Then we'll come back and I'll probably want to finish up domain 3 for us, okay? So go ahead and do your quiz. And then we're going to take a 15-minute break. All right, guys, let's go ahead and finish up for the day. So I'll put in the Signal group chat the weather call for testing Saturday or Sunday. I checked the weather again this morning, and it said it was just gonna maybe have freezing rain and some snow overnight on Friday. So we'll make the weather call. If it was up to just me, I'd probably just do it Sunday. But again, I just have someone coming in with the test center, so I just gotta see what's up with him. But by 6, 7 p.m. tonight, I'll make the call if we're going to do Saturday or Sunday, okay? Regardless of which day, whether it's Saturday or Sunday, it'll still be 15 packs total with increments every 2 hours. So at 08, 15 people, 10 o'clock, 15 people, 12 o'clock, 15 people, and 2 o'clock, 15 people, whether or not it's Saturday or Sunday, okay? So I'll put that out in the Signal group chat. I'll make the official call by tonight so everyone can be tracking. If anyone does not want to test this weekend, again, just let me know. Hit me up on Signal. But, okay, cool. Let's go ahead and finish up for the day. We're going to finish up Domain 3. Then we'll call it. For tomorrow, we're going to be in person again. And we'll probably just go from 9 to again 12, 12:30. And we're just going to do questions tomorrow, okay? So you guys can just spend all day doing questions. But okay, let's go ahead and continue. Or let's finish up for the day, really. All right, Domain 3.3.2, general data considerations and methods to secure data. So let's go over general data considerations, so data states. So we have 3 data states we're going to talk about here. Data at rest, that is data that is stored and not actively being processed, requires protection measures like encryption and physical security. So that's your storage. That's your hard drives and your computers. We have data in transit. So that is data that is moving through networks that's sending over the wire, right? So your client to web server architectures, anything that's being sent over the internet is data in transit. We have data in use. That is data that is being actively processed by an application on your system. So that's data that's being processed by your compute resources like your memory or your CPU. Other data considerations you have to worry about when it comes to protecting data is the data sovereignty. And this pretty much is based on the country you're operating in. So in the US, if you're transacting credit card information, you have to be in compliance with PCI DSS. If you're working with the government, you have to comply to different NIST standards. If you're processing EU customers' data, you have to be compliant with the GDPR. When we're looking at the different compliances based off a geographic location, we call that the data sovereignty. Data sovereignty. Then geolocation. Based off where your data is. So I could have a data center in Virginia, but if I'm processing EU customers' information in Virginia, I still have to comply with the GDPR, but I do not have to comply with the GDPR's regulations when it comes to data center protections. So to break that down a little further, processing data and then the geolocation and data sovereignty kind of intermingle in this way. Data center in Virginia. That physical data center, the physical access control, the security, that's going to be based off that geolocation's compliance standards and requirements. So if Virginia, or the US really, says, hey, do whatever you want with that data center, physically, for the power, for the HVAC, you do whatever you want. But if I'm hosting an e-commerce web service from a server in that data center in Virginia, and I'm processing EU customers' information, I have to be compliant with the GDPR as far as processing their information. But the GDPR's laws and how to protect data centers, it doesn't matter to me because my physical data center isn't physically located there. So it does get a little tricky, right, in that sense. Even though you have a data center located in Virginia and you have to comply with those laws, but if you're processing EU customer information, the processing, you have to follow the GDPR. But since you're not physically located there, other rules may not apply, okay? So methods to secure data. Let's go over the different methods. So geographic restrictions, again, just keep it in that same tune of complying with the laws of that local area. Encryption. So we want to protect our data. We're going to have to apply some sort of encryption. This could be full disk encryption for data at rest. This could be different in-transit encryption methods like IPsec, TLS VPNs. Hashing. So if we want to make sure that we keep our data's integrity, we can use hashing to verify it. So hashing involves transforming data into a fixed hash. What we mean by that is not changing the data from plain text to ciphertext. We mean creating a unique message digest from our original data. Data masking. And we went over this day one. Remember, Sec Plus does like to kind of repeat itself a little bit because we build our slides based off the exam objectives. So anyways, data masking involves obscuring specific data within a database to prevent unauthorized access while allowing the data to remain usable. Tokenization. Kind of already described this. This is how we do our Apple Pay or Android Pay. This involves replacing sensitive data elements with non-sensitive equivalents known as tokens. Obfuscation, can never say it right, involves deliberately making data or code ambiguous or confusing to prevent unauthorized understanding or modification. Data segmentation. This is when we logically separate data. So if we have servers, maybe we put that in VLAN 500 and those servers get their own VLAN 500 tag on their layer 2 header and they're part of their own subnet. And then we can apply security policy to that subnet and VLAN. And then maybe we have our databases in a different VLAN. So we have that logical segmentation there that requires a layer 3 device to be able to route traffic. Permission restrictions. So restricting the permission. So doing role-based access control, principal of least privilege to certain data. Again, we keep talking about that over and over. But, okay, let's go ahead and do our quiz. So go ahead and do quiz domain 3.3.2. And I'll put 2 minutes on the board here. All right, domain 3.4.1. Explain the importance of resilience and recovery in security architecture. So we're going to go over a little bit deeper into high availability, site consideration, and capacity planning. So high availability. So HA, you'll see that acronym a lot. This refers to systems designed to be operational and accessible for long duration without interruptions, typically by replicating data, having some sort of hot or hot standby configuration between a primary and secondary server or node. The objective is to have minimal system downtime so we can maintain our business operations. Load balancing versus clustering. Two methods to deliver high availability as far as like the networking goes. So load balancing and clustering are methodologies aimed at distributing workloads and computing resources. So load balancing, this is focused on distributing the network load. So this is incoming network traffic, sending it to different web servers based on some sort of algorithm or method. Could be like a round robin where it's just going through each server based on a one-to-one rotation. So connection comes in, go to server 1, connection 2 comes in, go to server 2. It could be weighted load balancing, where we're actually taking information about the server. So if server 1's at 90% CPU load and like 80% bandwidth load, then maybe all incoming connections we send to server 2. That's weighted, making kind of a more of an informed decision of how we load balance. Clustering. This involves linking multiple servers so they function collectively as a single, more powerful system. So this is us having a web server cluster. So maybe we have physically 5 servers, but all 5 servers are taking in requests and registered as trepatech.com. Other site considerations. So a hot site. So let's go over this. We've talked about this briefly, but hot, warm, and cold sites. A hot site is an external facility that is fully equipped and operational to take over business operations. So this is like a standby, a ready-to-go standby with minimal downtime to take over if your primary data center goes down or your primary site goes down. Warm site. A warm site provides a middle ground between a hot and cold site and is equipped with some but not all the components necessary for swift activation. So we're looking at maybe hours, like hours for a warm site to come up and, take over. Then we have a cold site. So this is just a backup facility that may have some infrastructure, power ready to go. It maybe has the hardware but not configured, not racked yet. Maybe has an ISP connection. Maybe you're paying for it, but it's not doing anything. So this can take a couple days, like 24 hours, 48 hours. That is a cold site. Other site considerations is geographic dispersion. So I kind of talked about this, that if you have a redundant site, whether that's a hot, warm, or cold site, or you're cloud-based, put it in different geographical regions so that the same geographic disasters don't affect both your data centers. And make sure when you're doing this, if you're doing it internationally, that you're worried about the data sovereignty as well, the compliance. Platform diversity. So platform diversity can be very important when it comes to maybe not being as vulnerable. So with multi-vendor environments, what's the pro here? Well, if we have a Cisco router and a Juniper router operating in a first hop redundancy architecture where one's primary, one's secondary. Now, this usually doesn't happen. This is a very out there example, but gets the point across. If there's a CVE for Cisco, well, that means our Juniper router is still good. It's not vulnerable. So you have that multi-vendor diversity, kind of helps you with vulnerability management. Now it increases it because if then they both have the vulnerability, you have 2 different patching systems, but it doesn't make you dependent on one vendor in case that vendor fails or has a major vulnerability. However, what's the con? 2 different service contracts, 2 different vendors you have to learn, so you get maybe some tech debt. Maybe you're paying for more expertise because you got a network engineer and you tell him you got to learn 3 different platforms. You might be paying him or her a little bit more. Multi-cloud systems. Same thing. It's just this is multi-vendor, but multi-cloud systems. Leveraging cloud services from multiple providers. This helps you with some risk mitigation in case there's a major outage from a single provider or service disruption. Continuity of operations. So continuity of operations is the practice of ensuring that essential business processes can continue during and after a severe disruption. Capacity planning. So if you know historically or you expect peak hours or a peak time, or if you're in retail and e-commerce, a peak season, make sure you've planned for that capacity. With the cloud, this makes it a little bit easier, the ability to elastically scale up and only pay for what you need. But in your data center, maybe you do have some upfront capital expense to make sure that you can to make sure you can meet that capacity for your peak seasons. All right, let's go ahead and do our quiz. I'm going to put another timer up there for 2 minutes. All right, last slide deck we're going to go over today. So we're going to go over testing, backups, and power when it comes to recovery in our architecture. Okay, so the different types of testings, the different type of exercises and tests we can do in our environment or in our enterprise that can help us be prepared if a disaster happens or if a breach happens. So a tabletop exercise. So tabletop exercises are structured discussions used to examine and evaluate an organization's plan and also the capabilities in a simulated crisis. So when it comes to, let's say we're worried about incident response. So as an organization, we want to make sure that everyone understands their roles and responsibilities in case there's a major data breach. Now, this isn't just the IT team. This does involve major stakeholders. So marketing may have a play. Our sales team may have a play with their customers when we have a major outage or breach. Our PR team, our finance team, our accounting team, they all have a role to play in incident response in a large enterprise. So a tabletop exercise is we gather around the meeting table, and maybe we have representatives from each major division, shop, department, and maybe it's management, and we say, do you understand your role if A through B happens, if this incident happens? That's a tabletop exercise. It's really to identify the gaps that we may have as far as everyone's understanding of their roles. And it may also come out, well, we don't have a plan for this, so I'm glad we did this exercise, so now we can backwards plan from there. A failover and simulation. So failover and simulation testing involves evaluating the resilience and performance of systems by simulating failure scenarios and validating that backup systems operate effectively. So failover. This is actually taking a system down and making sure your backup works. So let's say you're in a hot standby configuration of like your wireless LAN controllers. So you take the hot wireless LAN controller down and you want to make sure the standby does take over. So you put in a maintenance window and do that. A simulation involves creating a controlled environment to mimic real-world scenarios. So maybe we have some sort of sandbox environment of our actual enterprise, and we start exploiting it and doing blue team exercises to make sure we know what to do. Okay, we'll move on there. Backups. So backups are another very important part of our resiliency, and we have multiple different backup strategies. So we have on-site, off-site. So on-site backups provide quick access for data recovery, while off-site backups are essential for protecting against local disasters. So let's think of what a backup does on-site. Well, maybe it's there if we have a major outage from something in our tech suite. So in our stack, we pushed bad code, and now we have an outage that's on us. It's a technical error. Well, we have good backups on-site. That's going to be good to back up our data. But let's say it's a power outage, though. Having those storage arrays for our backups that are in the same data center as our production environment, that does us no good. So sometimes the offsite backups are required. Really the best way to do it is maybe to have both if your organization can do that. And then the frequency. How regularly should we back up? This all determines your risk appetite for data loss. So you can have daily, weekly backups. And then encryption. Are we encrypting our backups? So we know we have full disk encryption on like our storage area networks, but what about our backup drives or our backup arrays? Some other forms of backup, snapshots. So snapshots are point-in-time records of a system, typically VMs. So if a VM gets exploited and you have a snapshot from a week ago when it didn't have that ransomware exploit on it, you use that snapshot. Recovery. So this involves strategies and plans to restore systems and data to operational status after a loss or corruption. And then replication and journaling. So replication is to ensure that data is continuously copied to different locations. So replicating it across our high availability architecture. So different regions if you're in the cloud, different geolocated data centers. And then tracking the changes is journaling. This could be as simple as just having like a Word document log for journaling or having a more robust system like maybe something in Confluence or Jira. And then power. What kind of power redundancy do we want? So we could have generators. Generators for more of a blackout scenario, right? So if we have a blackout, major outage, power outage, like someone decides to shoot up our generator or, the power grid, that happened in like Southern Pines, I think about a year ago. Anyways, we're going to need a generator. We're going to need a generator to last us 12 hours, 24 hours, 36 hours. And maybe that generator's gas powered, so we have someone on call to go fill it up. Or it's like natural gas powered, which is totally possible. We do that out in the woods a lot. Anyways, that's for major sustained operations for extended period of time. And UPS, that's just immediate backup power. That's just a battery. That also helps regulate brownouts. So if you're ever in like a country that doesn't have stable power and they have rolling brownouts, and UPS can help regulate that. But it's really just to bridge the gap between power outage and then it getting fixed and UPS quickly. All right, awesome. So that's going to be it for today, guys. So tomorrow, I'm going to put any sensitive information out in our Signal group chat. But tomorrow we'll come in at 09 and we're just going to be practicing questions. I will make the weather call and decision for testing tonight. Give me till about 6, 7 p.m. I'm just going to keep checking the weather channel. And if it's snowing in the morning and during the day Saturday, we'll move to Sunday. If it's not, if it's supposed to just be like a little rain and like cloudy, we're going to come test Saturday, okay? Just keep in contact on Signal if anything changes as far as testing for you guys. I'll see everyone tomorrow. And yeah, everyone have a good day. Make sure you mourn President Jimmy Carter for giving us this half day.